Welcome to Earth Analyst. Tonight, we journey far beyond our familiar skies to a world both alien and strangely captivating. A world of red deserts, whispering winds, and silent canyons carved over eons. This is Mars. Imagine a place where the sun is only half as bright as on Earth, where the days are just slightly longer than ours, and the nights stretch into vast, icy darkness. Life here, if it exists, would be a delicate miracle, a careful dance with a planet that seems inhospitable at first glance. In the thin, cold air and across the endless rust-colored plains, possibilities linger. Perhaps microbes cling to hidden pockets of water beneath the surface. Perhaps human footprints one day mark the fine Martian dust, leaving impressions that last for centuries. Every crater tells a story of cosmic encounters. Every canyon hints at ancient rivers that once flowed. In this silent landscape, the rules of life are rewritten. Gravity is weaker. The sky glows a dusty pink, and storms can rise to heights and ferocity unimaginable on Earth. As you settle into this story, allow your mind to drift slowly across Martian plains and cliffs. Let the imagination move gently through domed habitats, robotic explorers, and red-hued horizons stretching endlessly. Here, in the quiet of an alien world, there is a rhythm to be discovered, a pattern of possibility, a vision of life surviving against odds. Close your eyes or keep them open and picture a world that challenges everything we know about living. For tonight, Mars is not just a planet, it is a question, a dream, and perhaps a future home. We often picture ourselves one day building colonies on Mars, learning to breathe in its thin, cold air and adapting to its rust-colored deserts. Perhaps in the distant future, humans will terraform parts of it, softening its harsh edges to resemble the familiar blues and greens of Earth. But before we leap forward into this vision of tomorrow, there is another question worth pondering. What if Mars was once not a barren world, but a planet that resembled Earth in its prime? What if, in the distant past, Mars was capable of supporting life similar to ours, or even the first home of a human-like species? We do not need absolute proof to imagine this. We only need to consider the evidence already revealed by science. Mars is not a random point of light in the sky, is a planet marked by rivers that carved deep valleys, by minerals that form only in water, and by traces of oceans that may once have stretched across its surface billions of years ago. If lakes, rivers, and seas once existed there, it was a world with the conditions to nurture life. And if life found a foothold, then the emergence of intelligence, though perhaps rare, becomes a tantalizing possibility. This idea challenges our conventional sense of time. We usually picture it as a straight line. Life begins on Earth, evolves slowly, and eventually produces humans. But when we include Mars in the story, the timeline grows more complex. The sequence may bend, intertwine, or even suggest that life began elsewhere before reaching Earth. Mars could have hosted organisms long before the first cells appeared on our planet. Perhaps Mars was the first stage, and Earth the second act of a cosmic drama spanning billions of years. At first glance, this may seem improbable. Earth is abundant with fossils, artifacts, and geological records of life's evolution, while Mars appears silent, empty, and uninhabited. But silence does not equate to absence. A civilization or a thriving biosphere on Mars billions of years ago could have left almost no trace today. Over such vast stretches of time, cosmic impacts, shifting landscapes, erosion, and the planet's own geological changes could erase all evidence. Even here on Earth, with its protective atmosphere and dynamic geology, entire civilizations have vanished within only a few thousand years, leaving little more than whispers in the sediment. Imagine a Mars where rivers shimmered under pale sunlight, where towering mountains and valleys offered shelter, and where simple organisms might have floated in ancient lakes. Perhaps life evolved, adapted, and changed, only to vanish as the planet's atmosphere thinned and its waters disappeared. What remains now are Cinza Valley here, a mineral deposit, there hints of a world that once thrived. And in those silent deserts and canyons, imagination allows us to reconstruct what might have been ecosystems of microbial life, strange skies with dust storms rolling across plains, and maybe, just maybe, a civilization so old and distant that we cannot perceive it anymore. Considering this possibility reminds us that life's story may not belong to Earth alone. The universe is vast, and the narrative of intelligence may span planets, not just continents. It invites wonder, a humility, and a patience to accept that some chapters are hidden beneath layers of dust and stone. Perhaps Mars whispers its secrets only to those willing to listen with imagination. In this way, contemplating ancient Mars transforms not just how we think about the planet, but how we understand ourselves, part of a larger, more mysterious story, a narrative stretching beyond a single world, across timescales so immense they defy ordinary comprehension. Whether that loss was caused by a shifting climate, a thinning atmosphere, or some massive impact from space, the consequences would have been profound. Life struggling to survive on Mars would have faced a choice: adapt to increasingly hostile conditions or seek refuge elsewhere. In this scenario, Earth, with its thicker atmosphere, abundant water, and protective magnetic field, would have been the natural sanctuary. This does not imply that humans, as we know them, simply traveled across the void of space and landed on our planet fully formed. The idea is subtler, more nuanced. Perhaps only microscopic seeds of life made the journey, hitching a ride on rocks ejected from Mars by asteroid impacts or carried by cosmic dust. Perhaps evolution on Earth nurtured these seeds over millions of years, transforming them into the complex organisms and eventually humans that inhabit our planet today. Either way, the question remains: could Mars have been the first home of life that eventually reached Earth? In this exploration, we will move slowly, taking time to imagine the possibilities. We will trace the evidence for a warmer, wetter Mars, imagining lakes shimmering under pale sunlight, rivers carving deep valleys, and oceans stretching across plains. We will consider how life, if it existed, might have adapted to these conditions. We will wonder at the rise of a civilization, its achievements, its challenges, and perhaps its ultimate decline. And we will ponder why the signs of such a history, if they exist, are so elusive, hidden beneath dust, rock, and time. Today, Mars appears as a frozen desert, its surface a rust-colored wasteland. Its atmosphere is thin, letting in harsh ultraviolet rays from the sun. Temperatures plunge far below freezing, and dust storms sweep across plains that stretch for hundreds of miles. To look at it now is to imagine only barrenness. Yet, appearances can be deceiving. Mars carries its ancient memory in the shape of its landscapes. Valleys stretch for thousands of kilometers, scarred into the crust like the marks of rivers long vanished. Vast canyons, deeper than anything on Earth, wind across the planet, hinting at tectonic forces and flowing water that once carved them. Channels snake across plains, their dry beds echoing the patterns of rivers on our own world. Ancient shorelines trace the edges of vanished seas, silent reminders that Mars once held liquid water in abundance. These features are not illusions. They are evidence of a planet transformed over eons, a world that could once have supported life in forms we are only beginning to imagine. Robotic missions have brought us closer to this reality. Orbiters have mapped Martian valleys, cliffs, and ancient lakebeds with incredible precision. Rovers have examined rocks, uncovering minerals that form only in the presence of water. Each discovery is a hint, a whisper of a wetter, warmer Mars that could have nurtured life long before humans walked the Earth. Even subtle details, the layers of sediment in canyon walls, the shape of craters worn smooth over millions of years, tell a story of change and decay, of a planet that evolved, thrived, and ultimately transformed into the harsh, cold world we see today. Imagining life on ancient Mars is like listening to a faint echo across time, piecing together a civilization or ecosystem that may have existed so long ago that every trace of it has almost disappeared. And yet, the possibility remains. Even if life never reached intelligence, even if no cities or structures survived, Mars may have been alive with microbial ecosystems, oceans teeming with microscopic organisms, and landscapes sculpted by wind and water. Each crater and canyon holds a memory of a time when Mars was vibrant, a canvas on which we can imagine the slow unfolding of life, adaptation, and struggle. To consider Mars in this way is to expand our sense of history, to see life not as confined to a single planet, but as a phenomenon that could stretch across worlds and eons. It reminds us that the story of existence is vast, complex, and filled with mysteries we may never fully solve, but mysteries that are worth dreaming about. Landers and rovers have slowly traversed the rust-colored plains of Mars, examining rocks, soil, and the subtle patterns etched into the planet's surface. Each step, each instrument reading, has revealed hints of a world very different from the cold, barren desert we see today. Minerals discovered in rocks could only have formed in the presence of liquid water. Chemical signatures suggest that Mars' surface, long thought hostile, was once gentler, capable of sustaining liquid and perhaps even life. Orbiters high above the planet have confirmed patterns in the terrain. River deltas, ancient lakebeds, and channels that branch outward like veins across the surface. Every formation strengthens the idea that Mars was once a world of flowing water. And wherever there is water on Earth, life finds a way. From ice-covered lakes in Antarctica to boiling hydrothermal vents in the ocean, life adapts, survives, and thrives. If Mars once held water in abundance, it is natural to wonder whether it once nurtured living organisms of some kind. The conditions may not have been perfect, but they could have been sufficient. And water may not have completely disappeared. Radar instruments have hinted at pockets of briny liquid beneath layers of ice, hidden reservoirs that might still harbor life in some dormant or extreme form. If confirmed, these underground refuges could be living worlds, untouched by the planet's harsh surface conditions. Mars remains a puzzle, a study in contrasts. Its landscapes feel familiar: mountains, valleys, and plains that echo deserts on Earth. Time seems to have slowed here. Ancient features remain preserved, like a museum of geological history spanning billions of years. To imagine Mars as humanity's first home, we must reconcile to visions the lifeless, frozen world we see today and the warmer, wetter, potentially vibrant Mars of the distant past. Every glance at Mars is a study in contradiction. Its surface appears barren, yet its details whisper stories of flowing rivers, standing lakes, and perhaps oceans. Almost everywhere, the marks of ancient water are evident: wide valleys cut deeply into the terrain, branching channels radiating outward, and delta-like formations where rivers may have once emptied into seas. These features are not the work of wind or lava. They are the unmistakable signatures of moving water, preserving a record of Mars' hidden history. The story begins billions of years ago. Evidence suggests that Mars once possessed a much denser atmosphere, thick enough to trap heat and maintain warmer conditions. Under this climate, liquid water could exist freely on the surface, forming rivers, lakes, and even seas. Rain may have fallen, carving valleys and shaping plains. Ice caps melted seasonally, feeding streams that carved channels into rock, leaving the landscape as a silent witness to the passage of water. If Mars could sustain water, could it have supported life? Could simple organisms have thrived in lakes and rivers, adapting to changing conditions over millennia? Could life have left microscopic traces hidden in sediments, waiting for the right moment to be discovered? These questions keep scientists exploring, sending rovers and orbiters to measure, record, and interpret every layer of Martian rock and dust. Mars today is quiet, cold, and seemingly lifeless. Yet, beneath its surface and etched into its landscape, it tells a story of transformation, a story of warmth, water, and the possibility of life. And as we study these ancient formations, we begin to imagine what it might have been like: rainfall pattering into lakes, rivers carving canyons, and perhaps, somewhere long ago, living organisms swimming in waters that now exist only as frozen memories. When we examine Mars through this lens, the dry riverbeds, canyon walls, and ancient shorelines scattered across its surface begin to tell a story. They are not random scars, but the remnants of a wetter, more Earth-like world, one where water flowed freely and shaped the land over millions of years. NASA's rovers have brought this story into sharper focus. Curiosity, exploring Gale Crater, has studied layers of sedimentary rock that could only have formed in the persistent presence of standing water. These layers, built up slowly over countless years by water carrying small particles, resemble the lake beds we find on Earth, offering a glimpse of Mars' liquid past. Another rover discovered tiny mineral spheres, affectionately called blueberries, composed of hematite. a mineral that on Earth typically forms in watery environments. They are subtle but telling witnesses of ancient Martian lakes. Chemical analyses of rocks reveal further clues. Some stones show evidence of long-term exposure to stable liquid water, indicating that Mars was not only wet, but that these waters persisted long enough to transform the surface chemically and perhaps biologically. By combining data from orbiters and rovers, the picture becomes even more compelling. High above, orbiting instruments have mapped out vast regions where lakes once existed. Gale Crater itself is layered with sediments that speak of a large, enduring body of water, one that may have lasted for millions of years. These were not ephemeral puddles, but environments capable of supporting life in the forms we understand on Earth. Water alone does not guarantee life, but it sets the stage for it. On our planet, wherever water is stable, life finds a haven in the most extreme environments, from boiling hydrothermal vents to acidic lakes and icy glaciers. This makes the evidence of ancient water on Mars profoundly significant. It does not confirm that life arose there, but it shows that the planet once had the essential conditions for life to take hold, if we allow our imagination to extend further. These findings open the door to tantalizing possibilities. Could microbial life have emerged, thrived, and evolved on Mars long before Earth had even begun its complex dance of life? Could more complex organisms, even intelligent life, have once walked the Martian surface, leaving only the faintest hints that might still be buried under dust and rock today? Now, Mars is harsh. Its thin atmosphere cannot hold warmth or liquid water at the surface. Temperatures plummet below freezing. Exposed water either sublimates into the thin air or freezes instantly. Yet the landscape retains the fingerprints of its past. Dry riverbeds stretch across vast plains. Ancient deltas mark the edges of former lakes, and minerals whisper chemical stories of water long gone. Each crater, ridge, and valley is a silent testament to a time when Mars may have been more hospitable. The planet's surface, though now cold and barren, preserves these ancient features as if frozen in time. It is a world of contrasts, barren now, yet alive in memory. By studying these traces, scientists can reconstruct an image of early Mars, a planet with flowing rivers, standing lakes, and perhaps even seas, a world capable of sustaining ecosystems and maybe life. Mars today may appear lifeless, but the evidence tells another story. It hints at a past filled with movement, energy, and the possibility of life. The dry beds, layered rocks, and mineral deposits are echoes of a dynamic, watery past, a chapter of the solar system's history waiting to be read. Each rover wheel pressed into Martian soil, each satellite orbiting above, peels back layers of silence to reveal a planet that was once vibrant, dynamic, and full of potential. As we imagine this ancient world, it invites a question that lingers. What else might Mars still hold beneath its dusty surface? Could there be pockets of water hidden under ice? Could life, in some hidden form, persist even now? Mars may seem dormant, but its story is far from complete, and its secrets continue to beckon us across the void. If humans, or anything like humans, ever called Mars home, this was the world they would have known. A world painted not only in red dust, but also in the deep blues of flowing rivers. shimmering lakes, and perhaps even vast oceans. A world where life was not merely possible, but potentially thriving. This is why the search for water on Mars is so crucial. It is not simply a scientific quest. It is a search for the roots of life itself, and perhaps even for the beginnings of our own story. When we look at Mars and Earth today, they seem like polar opposites. Earth teems with oceans, forests, and creatures of every shape and size. Mars, by contrast, is a cold, barren landscape, silent under its thin, rust-colored sky. Yet, if we travel back billions of years, the contrast softens. Both planets were young, dynamic, and in the process of shaping their surfaces, their atmospheres, and their destinies. Both may have been capable of supporting life in its earliest forms. To imagine a Martian origin for life, we must compare these worlds at their infancy. On Earth, the oldest signs of life date back more than 3.8 billion years. Microbes thrived in shallow seas, harnessing sunlight or chemical energy. Water flowed abundantly across the surface. The atmosphere was thick enough to protect these fragile organisms, while a magnetic field shielded them from harmful solar radiation. This combination created a stable environment where life could gradually grow in complexity. Even after the atmosphere thinned and surface water vanished, subsurface environments might have remained stable. Underground aquifers, insulated from radiation and harsh winds, could have preserved liquid water for billions of years. On Earth, we know life thrives in deep subterranean environments, independent of sunlight, feeding on chemical energy derived from rock and water. Mars may have hosted similar hidden ecosystems, invisible to the eye, but potentially sustaining lifelong. After the surface turned hostile, the duration of habitable conditions also shapes the possibility of complex or intelligent life. On Earth, intelligence emerged over billions of years. If Mars only had a few 100 million years of surface stability, advanced life may not have had the opportunity to develop. But if subsurface niches persisted for much longer, evolution may have proceeded more steadily, even if slowly. Life could have experimented, diversified, and adapted in ways we cannot yet imagine. Evolution is not a fixed clock. On different worlds, it can accelerate, slow, or take unexpected paths. Moreover, life on Mars might not have needed to reach full complexity to influence Earth. Even microbial or early multicellular forms could have been transported across space via rocks ejected by impacts, a process known as lithopanspermia. These tiny travelers could have carried the seeds of life, spreading biology from one world to another. The story of Mars is therefore not just about survival on a single planet, but about a larger cosmic network of possibilities. It invites us to imagine a history where life began, flourished, and perhaps even faced extinction before ever touching Earth. Mars, in this vision, is both a cradle and a teacher. Its rivers, lakes, and ancient seas are not just geological features, but reminders of what is possible in the universe. Its decline is a lesson in fragility, showing how delicate the conditions for life truly are. And yet, the faint traces that remain hint that life, in whatever form, could endure in hidden spaces. To understand Mars is to expand our sense of time, to see that life might not be confined to one planet or one epoch. It is to imagine that Earth is part of a larger story, one in which Mars played a role long before our own species existed. Even today, as we gaze at the red planet through telescopes or robotic eyes, we are looking at echoes of a world that may have been alive. Valleys carved by water, minerals shaped in ancient lakes, and ice that preserves the memory of past climates. These are signposts pointing to a deeper history. If humans or their distant ancestors ever arose on Mars, they would have known rivers, rains, and clouds. They might have gazed at a sky tinged with blue and felt the warmth of a denser atmosphere. They may have lived, adapted, and perhaps even wondered about the future as conditions slowly shifted toward the cold, dry world we see today, as we have seen the rivers, lakes, and possibly shallow seas of ancient Mars suggest that for hundreds of millions of years, or perhaps longer, the planet offered at least pockets of stability. Water, warmth, and energy were present, creating niches where life could begin, diversify, and perhaps even become complex. In imagining a Martian civilization, we must allow for the possibility that life adapted in ways entirely different from Earth. Perhaps it thrived underground, in caves or beneath ice, leaving no visible marks on the surface. Perhaps it constructed structures from materials that have since been eroded or buried. Over billions of years, radiation, dust storms, and meteor impacts would have obliterated the fragile traces we might hope to find today. The disappearance of a civilization on Mars, if one ever existed, could have been gradual. As the atmosphere thinned, water disappeared, and surface conditions deteriorated. Survival may have required migration below ground, adaptation to harsher climates, or if intelligent life existed, plans to leave the planet altogether. Entire generations could have witnessed the slow transformation of their world, learning to survive in its increasingly hostile environment. What knowledge, art, or technology they developed may have been lost completely, leaving only whispers of a once living world embedded in rocks and sediment. If even microbial life made the journey from Mars to Earth on rocks ejected by impacts, as some scientists speculate, then the legacy of that ancient Martian biosphere may already be intertwined with life on our own planet. The seeds of biology could have crossed the void of space, carrying forward the potential for evolution that eventually produced the rich tapestry of life we see on Earth today. And if intelligence ever arose on Mars, even briefly, we can imagine a civilization that witnessed its own decline, knowing that their world was changing, and that survival might require leaving or adapting in ways that we can barely comprehend. In this vision, Mars is not merely a lifeless neighbor, a cold red planet in the sky. It becomes a stage for history, a laboratory of evolution, and a mirror to our own planet's past. Its valleys and canyons, its dried riverbeds, and its ice-capped poles are not just scenery. They are records of time, of change, and of possibility. The planet invites us to imagine the lives that may have unfolded there, to contemplate a story that has left almost no trace, yet lingers in the subtle signatures of rocks and minerals, in the faint shapes of channels, and in the very tilt and orbit of the world itself. Ultimately, the question is both scientific and philosophical. How do we measure life that no longer exists? How do we understand civilizations that may have vanished without a trace? Mars challenges our assumptions, asking us to think beyond the limits of visible evidence, to imagine a planet where life may have blossomed, flourished, and perhaps even built societies, only to vanish long before we arrived to witness it. And in imagining this, we also imagine ourselves, earthborn, but perhaps connected in ways we cannot yet prove, carrying within us the echoes of distant worlds and ancient possibilities. Mars, quiet and still now, may have once been a living, breathing, moving place. A planet where water carved valleys, life adapted to new niches, and perhaps even beings watched the sky and wondered about their future. The traces of that past are faint, scattered, and elusive. Yet the evidence, the shapes of the land, the minerals, and the silent testimony of billions of years, all invite us to consider the astonishing possibility that Mars was once not merely a world, but a home that may have played a role in the unfolding story of life, and in some way, perhaps even our own story on Earth. Survival on a changing Mars would have demanded ingenuity, adaptation, and perhaps a willingness to retreat beneath the surface. Underground caverns or ice-covered regions could have provided shelter from radiation and preserved water sources. Technology, if it existed, might have focused on energy capture, water management, and life support in ways we can scarcely imagine. Their cities, if they built any, may not have resembled our own at all. Perhaps they were temporary structures, mobile habitats, or bioengineered environments designed to endure shifting conditions. In this way, the traces of their existence could have been minimal, easily erased over billions of years, even in decline. The presence of such a civilization might have influenced Mars in subtle ways. Networks of canals, mined caverns, or agricultural terraces could have existed, but later vanished under wind-blown dust and slow erosion. Perhaps they left chemical markers in rocks, isotopic signatures in soils, or mineral alignments that we have yet to recognize. The very geology of Mars may contain whispers of intelligent activity, subtle as the trace of a footprint that fades over millennia. As we imagine this lost civilization, it is also necessary to consider its knowledge and culture. If intelligent life existed on Mars, they may have looked at the stars and wondered about other worlds, as we do today. Perhaps they observed the movements of planets, tracked the sun and moons, and speculated about life elsewhere. And perhaps, in their final centuries or millennia, they contemplated survival beyond Mars itself, whether through technological means, migration, or the preservation of life in ways that echo in the concept of panspermia. The decline of Mars would have been slow, relentless, and global. Rivers dried, lakes evaporated, and the thin atmosphere allowed harsh radiation to dominate the surface. Any society would have been forced to adapt or perish. Those who survived may have retreated underground, building hidden refuges, cultivating microenvironments, and maintaining knowledge and culture in secrecy. And yet, even in isolation, the passage of time would eventually obscure all visible traces, leaving the landscape silent and empty to an observer arriving billions of years later. This brings us back to the question of evidence. The face on Mars, pyramidal hills, and geometric features capture our imagination, but they are only the beginning of what might exist in forms we cannot yet detect. Just as ancient Earth civilizations can vanish almost entirely in a few thousand years, a Martian civilization could leave behind almost nothing visible. In their absence, all that remains are possibilities, geological hints, and the imagination that allows us to reconstruct their story. Mars, during that same era, appears to have been far from barren. Geological formations suggest that around 4 billion years ago, rivers carved valleys, lakes collected in lowlands, and oceans may have stretched across its surface. Its thicker atmosphere could trap warmth, volcanic activity may have shaped the land, and chemical reactions in rocks hint at the presence of liquid water for extended periods. In many ways, early Mars could have been a planet strikingly similar to young Earth. The key difference between the two worlds lies in longevity. Earth's greater size and stronger gravity allowed it to retain its atmosphere over billions of years. Its molten iron core generated a magnetic field that persisted, safeguarding the planet from the sun's stripping solar wind. Mars, smaller and weaker in gravity, lost its magnetic shield relatively early. Without that protection, the solar wind gradually eroded the atmosphere, and water on the surface either evaporated or froze. Over time, the once wet world became the frozen desert we see today. This difference in endurance is crucial. Earth could nurture life continuously over billions of years, but Mars may have had only a limited window, perhaps hundreds of millions of years, during which life could emerge. That window, though brief in geological terms, might have been long enough for simple life to develop, and, in a more speculative sense, for more complex organisms to evolve. We can imagine early Martian seas teeming with microscopic life, perhaps forming intricate ecosystems beneath the water's surface. Shores might have been lined with mineral deposits, preserving chemical fingerprints of this ancient biology. Volcanoes could have created warm oases, pockets of stability where life could persist even as the planet's atmosphere thinned. Perhaps, somewhere in those lost oceans, organisms experimented with ways to survive, adapt, and thrive in a world slowly turning hostile as the air thinned and the climate cooled. Life on Mars would have faced its greatest challenge. Organisms that survived would need to retreat underground, seek shelter in ice, or adapt to extreme conditions. Any civilization, if one had arisen, would have had to contend with diminishing resources, a fading sky, and the slow transformation of the planet into the frozen desert we see now. Over time, wind and meteorite impacts could erase cities, rivers, and even signs of biological activity, leaving a silent red world behind. Yet, the faint traces remain. Dry riverbeds, delta formations, and mineral deposits speak of a time when water moved freely. Sedimentary layers in craters whisper of ancient lakes. Beneath the ice, hidden pockets of briny water could still exist, preserving the possibility that life, in some form, remains secret, waiting to be discovered. To imagine Mars as the first home of life is to expand our sense of history, to see our own story not as a simple line on Earth, but as part of a larger cosmic narrative. It is to wonder whether life began not here, but there on a planet that once flowed with water, teeming with potential, and perhaps, for a fleeting moment, alive in ways we have yet to comprehend. But eventually, conditions on Mars would have grown harsher, challenging any life or civilization that once flourished. Survival would have demanded resilience in the face of a slow, relentless decline. Unlike Earth, whose thick atmosphere and magnetic field preserved stability over billions of years, Mars gradually lost its protective layers. The air thinned, temperatures dropped, and water either froze or evaporated. Any ecosystem or intelligent society would have needed to adapt quickly or vanish. When we compare ancient Mars to ancient Earth, it is not only the physical environment that matters, but also timing. Mars may have been habitable earlier than Earth. Its surface cooled faster, allowing liquid water to exist while Earth was still settling into stability. In this view, Mars could have served as a kind of prototype world, a testing ground for life itself, a place where organisms or even proto-human civilizations might have emerged long before Earth was ready. If humans, or the seeds of humanity, originated on Mars, they may have evolved during this early habitable chapter, before Earth developed its oceans, continents, and thriving ecosystems. Earth, in turn, would have become a second stage in the story of life, a world inheriting existence from a vanished Martian past. Life's survival, then, is not merely a tale of Earth, but a saga woven across planets, shaped by the rise and fall of distant worlds. Placing early Mars alongside early Earth softens the stark contrasts we see today. Both planets were once warm, wet, and capable of supporting life. Both had rivers, lakes, and potentially oceans, their surfaces sculpted by liquid water. The question is not simply which planet was more hospitable, but which was first, and whether life could have begun on Mars, only to continue later on Earth. To imagine humans or pre-human life on Mars before Earth, we must ask a fundamental question. Could Mars have been truly habitable? Not briefly, but for extended periods of time. Evidence suggests that it may have been, at least during certain chapters of its early history. Habitability requires three basic ingredients: liquid water, an atmosphere thick enough to provide pressure and warmth, and sources of energy for living organisms. Water is the most immediate clue. The Martian surface is etched with valleys and channels that defy explanation without it. Minerals such as clays, sulfates, and hydrated salts discovered by rovers point to long-term interaction with liquid water. Layered sedimentary rocks in craters and basins closely resemble deposits formed in ancient lakes on Earth. These features are not the marks of fleeting moisture, but the legacy of persistent flowing water beyond water. Energy would have been abundant. Volcanic activity, chemical reactions in rocks, and solar radiation could have provided the fuel for early metabolic processes. These conditions suggest that Mars was not only wet, but dynamic, a planet where energy flowed, rocks shifted, and life had the opportunity to take hold. Even the planet's topography hints at habitability. Low-lying basins could have held lakes or shallow seas. River networks suggest cycles of rainfall, runoff, and perhaps seasonal weather patterns. Ice caps at the poles may have stored water and regulated climate. Early Mars was a complex world, with environments that may have supported diverse forms of life. From microscopic organisms to more sophisticated life forms. If life ever existed, its traces would be faint. Billions of years of solar radiation, meteorite impacts, and shifting landscapes could erase the evidence. Yet, in valleys, crater beds, and mineral deposits, we may still glimpse whispers of that ancient world, a record of water, energy, and the possibility of life. We begin to see it not as a dead, lifeless desert, but as a planet that once pulsed with potential. It is a world where life may have tested itself, adapted, and perhaps faced extinction long before Earth had even formed its first oceans. The story of Mars is not only a window into its past, but also a mirror reflecting what life, including humanity, might have been in the earliest days of the solar system. Each valley, each mineral layer, each ancient shoreline is a clue. They whisper of a world where the struggle for survival was real, where water shaped landscapes, and where life, if it existed, would have experienced triumphs and failures, abundance and scarcity, just as life does on Earth today. Even now, Mars retains its mysteries. Buried beneath ice or hidden in minerals may lie the faint traces of biology, waiting for us to uncover them. Imagining humans or life on Mars before Earth invites us to rethink not only the history of our planet, but also our place in the cosmos. Perhaps life is not unique to Earth. Perhaps it began elsewhere, and Mars is the first chapter of a story that continues here. On our blue and green world, these signs suggest that water persisted on Mars for thousands, even millions of years. The valleys, lake beds, and mineral deposits all point to stable conditions where liquid water could exist, carving the landscape slowly but steadily. Early Mars' atmosphere was far different from the thin, cold air we see today. Models indicate it was once thicker, richer in carbon dioxide, and capable of creating a greenhouse effect that trapped heat and kept surface water from freezing immediately. While still not as temperate as early Earth, this climate could have been warm enough for long stretches of time to allow water-dependent life to emerge and survive. Energy was not lacking either. Mars' massive volcanic regions, including Olympus Monsta, volcanic heat could provide warm niches. Chemical reactions in rocks could supply energy, and hydrothermal systems might have mirrored those on Earth, where some of the earliest life forms thrived deep in the oceans near vent systems. If microbial life could survive in such extremes on Earth, similar Martian environments might have nurtured life as well. Taken together, water, atmosphere, and energy suggest that Mars was far from barren. It was a world with pockets of potential, where ecosystems could have existed, perhaps not everywhere, perhaps not for eternity, but long enough for life to take root. On Earth, life remained microscopic for billions of years before evolving into larger, more complex forms. Mars may have followed a similar pattern, with microbial life dominating its early oceans and lakes. Yet, the possibility remains that certain Martian regions, with stable conditions and abundant energy, might have allowed life to progress more rapidly. If this were true, then imagining the existence of a Martian civilization, or at least intelligent life, is less fantastical than it might first appear. Habitability is not the same as habitation, and we must be cautious. No fossils or indisputable biological markers have yet been found. The surface of Mars today seems lifeless, silent, and frozen. Yet absence of evidence is not evidence of absence. Over billions of years, erosion, impacts, radiation, and shifting terrain could erase nearly all signs of life. leaving only subtle hints in rocks, minerals, and landscapes. What remains is a planet that silently tells its story through valleys, channels, and sediments. Each formation is a whisper of a time when water flowed, when chemical energy was abundant, and when life may have had the chance to flourish. Mars may have been, for a fleeting period, one of the most promising places for life in the solar system. If that is so, the next question naturally follows. How far could life have gone? Could microbial ecosystems have evolved into more complex organisms? Could intelligent beings have developed and shaped their world before decline set in? As we ask these questions, the mind is invited to wander across ancient Martian landscapes. Imagine rivers reflecting the pale sunlight, shallow lakes brimming with microbial life, and volcanic plains releasing heat into the cold Martian night. Picture a world that was harsh, but alive, dynamic, and full of possibility. Every valley and sediment layer becomes a testament to the planet's potential. Even now, buried beneath ice or dust, Mars may hold secrets that challenge our understanding of life, offering glimpses of what was once possible. By studying Mars carefully, we are not merely looking at a distant, cold planet. We are looking back in time at a world that may have nurtured the earliest chapters of life in our solar system. Each rover, each orbiter, and each sample returned brings us closer to understanding what Mars once was and what it might still be, hidden beneath its frozen surface. And so, the question remains open. Could Mars have been habitable, not briefly, but long enough to allow life to begin, thrive, and perhaps even think, dream, and explore? The evidence suggests yes. Water, energy, and atmosphere existed. Stability persisted for long periods. Mars was not a barren desert, but a world of potential, waiting for life to write its story upon it. How long did Mars remain in that habitable state? And was the window long enough for life to emerge, evolve, or even flourish in ways we cannot yet detect? To explore these questions, we must step back billions of years to a time when Mars was not the cold, dry desert we know today. Its surface may have been shaped by flowing rivers, vast lakes, and perhaps even shallow seas. Rain may have fallen, carving valleys and nourishing the land. The planet's atmosphere would have been thicker, capable of trapping heat and maintaining the pressure necessary for liquid water to exist today. Mars' atmosphere is less than 1% the thickness of Earth's, composed primarily of carbon dioxide. With traces of nitrogen and argon, it cannot hold heat, cannot sustain oceans, and cannot protect surface water from freezing or sublimating into the thin air. Yet ancient features tell a different story. Dry river valleys stretch across the surface. Delta formations mark where rivers once emptied into lakes. Ancient shorelines suggest water once lapped against the land, forming long-lasting bodies capable of supporting ecosystems. For such water to remain stable, Mars must have possessed a denser atmosphere, one that kept the planet warmer and maintained sufficient pressure. Scientists believe this protective envelope was gradually lost. Unlike Earth, Mars lacks a strong global magnetic field. Our planet's magnetic field shields the atmosphere from the relentless solar wind. Mars may have had its own magnetic shield billions of years ago, but evidence indicates it weakened and faded early in its history. Without that protection, Charged particles from the sun slowly stripped away the air, thinning the atmosphere over hundreds of millions of years. As the atmosphere vanished, the climate shifted dramatically. Surface temperatures dropped, water either froze or evaporated, and the gentle rivers and lakes disappeared. What was once a potentially life-friendly world became a frigid desert, harsh and barren. Yet, before this long decline, Mars may have enjoyed periods of surprising stability and warmth. For millions of years, it may have had a climate capable of supporting lakes, rivers, and perhaps even shallow seas environments where life could emerge and persist. Volcanic activity may have provided heat and chemical energy, creating pockets of habitable land. Mountains and valleys may have sheltered microclimates where temperatures and moisture were more favorable. For life, even microbial life, such niches could have been enough. If life arose in those early epochs, it may have thrived quietly, leaving only subtle marks in rocks and minerals, waiting billions of years for us to uncover them in this vision. Mars was far more than a dead and barren planet. It was a world of subtle motion, gradual change, and quiet possibility. Rivers carved the surface over eons, tracing sinuous paths across plains and through valleys. Lakes shimmered in basins, their edges shifting with seasonal rains, while shallow seas may have reflected clouds drifting across a pale sky. The atmosphere, denser than today, trapped warmth and allowed liquid water to persist, shaping the land in ways both familiar and alien. Though not Earth, Mars may have been a cradle for life, offering enough time and stability for the first seeds of biology to take root. Even now, in the silent deserts and ice-capped plains, traces of that past remain. Valleys, deltas, and ancient shorelines whisper of rivers that once flowed and seas that once lapped against the land. Climate models suggest that with a thicker carbon dioxide envelope, surface temperatures may have been high enough to sustain liquid water widely. Clouds would have formed, rain may have fallen, and seasonal cycles could have driven winds, erosion, and renewal. The sky may have been tinged blue, mirroring Earth's early vistas, and landscapes dotted with lakes, streams, and shallow seas that now exist only in memory. The duration of this habitable epoch is debated among scientists. Some evidence points to a window of only a few 100 million years, enough perhaps for microbial life to arise. Other studies suggest that habitable niches, protected valleys, geothermal hotspots, or underground aquifers could have persisted much longer, even into Mars's colder stages, providing refuges for life over 1 billion years. Volcanic regions may have offered warmth and chemical energy, while pockets of liquid water beneath ice sheets could have sustained ecosystems hidden from view. The story of Mars's climate and atmosphere is one of slow decline rather than sudden catastrophe. Unlike Earth, which retained its atmosphere and liquid water through a combination of gravity, a magnetic field, and geological renewal, Mars gradually lost its ability to sustain surface life. Its magnetic field faded, the solar wind stripped away the air, and the once warm rivers and lakes began to disappear. For any life or civilization that arose there, survival would have become an ever-mounting challenge. Conditions that seemed reliable at first slowly became precarious. Air thinned, water vanished, and temperatures dropped. This slow unraveling may help explain why the Martian surface today appears so empty and silent. Billions of years of exposure to radiation, wind erosion, and shifting sands have erased much of what was once tangible. Yet, Mars remains a planet caught between two identities: the habitable, watery world it once was, and the frozen desert it has become. If humans, or their ancestors, truly called Mars home before Earth, they would have witnessed this transformation firsthand. They would have walked along flowing rivers, gazed across lakes and shallow seas, and felt the warmth of a protective atmosphere. And over time, they may have watched their world gradually decline, a subtle and inexorable shift toward the cold, arid landscape we observe today. The atmosphere and climate of ancient Mars are not just scientific details. They form the stage on which the story of survival, adaptation, and perhaps migration could have unfolded. If Mars once possessed conditions suitable for life, a pressing question emerges. How long did these conditions last? Time is critical when imagining the evolution of life. On Earth, it took billions of years for life to move from simple, single-celled organisms to complex creatures, and eventually to humans. If Mars only remained hospitable for a brief geological moment, life there may never have progressed beyond its simplest forms. Yet, evidence points to liquid water on Mars's surface around 4 billion years ago. At that time, the atmosphere was thicker, the climate warmer, and the rivers and lakes could have persisted for extended periods. Some researchers estimate this habitable window lasted several 100 million years, a blink in geological terms, yet long enough to allow life to begin its journey. Other studies hint at more complex possibilities. Perhaps habitability came and went in cycles. Volcanic activity might have released heat and gases. Asteroid impacts or shifts in the planet's tilt may have temporarily melted ice, restoring lakes and rivers across localized areas. In this scenario, pockets of life could have survived for longer, scattered both in time and across Mars's surface. Technology may have evolved specifically to achieve this goal. Vehicles capable of leaving the Martian surface, methods to sustain life in transit, and ways to land safely on another planet would have been developed gradually over centuries or millennia. Even if the journey seemed impossible at first, the pressure of survival may have driven innovation at a pace unmatched on Earth, where conditions were stable. The migration itself would have been monumental. Entire families, communities, or perhaps the seeds of life itself would need to be preserved during transit across the void. Any failure could have meant extinction, which underscores the courage and foresight required. The act of leaving Mars would not have been a single event, taking decades or longer to ensure that life survived the journey and could thrive on a new world. And yet, as they looked back, the red planet would have been both home and tomb. Its rivers dried, its skies pale, and its landscapes scarred by the passage of time and erosion. The memory of Mars would have lived on only in stories, in cultural traditions, or perhaps in biological imprints carried across the cosmos. If this journey did happen, Earth became the new stage for life to continue its story. Rivers, oceans, and fertile soils welcomed those who arrived, offering stability previously unknown. What had been fragile and impermanent on Mars could now endure, giving evolution the time and space to produce what we know today as human civilization, it becomes a sanctuary, a place where the seeds of life, perhaps even the seeds of civilization itself, could grow anew. The move from Mars to Earth, whether by chance or design, would have been a journey not just across space, but across opportunity. Here, on a world with stable oceans, protective atmosphere, and fertile soils, life had the chance to flourish in ways that Mars could no longer support. In imagining this transition, it is not necessary to picture massive spaceships or technology as we know it. The transfer could have occurred gradually, in ways subtle and almost invisible to us. Microbial life might have hitchhiked on meteorites, spreading across continents and oceans once they arrived. Or perhaps, if a civilization existed, early travelers may have carried knowledge, culture, or genetic material with them, planting the first sparks of life that would eventually evolve into humanity. Earth, in this sense, becomes the second chapter of a story that began long before our planet was ready to tell it. The harsh lessons of Mars' adaptation, resilience, and ingenuity would have been carried forward, embedded in the very essence of life that reached our blue world. Our curiosity, our drive to explore, may be the inherited echo of ancestors who once faced the slow death of a red planet and dared to seek a new beginning. The evidence of Mars's past life, now hidden beneath layers of dust and rock, serves as both a reminder and an invitation. It reminds us of the fragility of worlds and the relentless force of time. It invites us to look beyond Earth, to consider the possibility that the history of life is not confined to a single planet, but woven across worlds, stretching into the depths of the cosmos, in the silence of its deserts, the rust-colored plains, and the ice-capped poles. Mars tells a story of beginnings, challenges, and perhaps departures. And in that story, we find a reflection of ourselves, a species shaped by survival, driven by curiosity, and always searching for a place to call home. It becomes a sanctuary, a refuge where the legacy of Mars could continue even as the red planet faded. If this is true, then humanity carries more than Earth's history. It carries echoes of Martian beginnings, fragments of a world that taught survival in extremity. As Mars slowly lost its atmosphere, water retreated into ice caps or vanished entirely, and the one-swarm rivers dried into ancient scars, Earth emerged as a stark contrast. Here was a world stable, abundant, and forgiving, where life could take root and flourish without the constant struggle against collapse. For those leaving Mars, whether through biological transfer, meteorite travel, or some other unknown means, Earth would have seemed a promising refuge, a second chance for life. Its thicker atmosphere provided warmth and protection. Its oceans, deep and vast, offered water in abundance, moderating climate and sustaining ecosystems. The planet's gravity was stronger, keeping gases anchored and maintaining conditions suitable for long-term life. Magnetic fields shielded the surface from harsh solar winds. Unlike the vulnerable plains of Mars, tectonic activity-shaped continents brought nutrients to the surface and created dynamic landscapes where ecosystems could thrive. To a civilization accustomed to scarcity, unpredictability, and radiation, Earth would have appeared as a sanctuary of balance. Forests, rivers, and plains could support both simple and complex life. Seasonal rhythms would guide agriculture migration, and settlement. The climate was consistent enough to allow for long-term planning. Even storms, earthquakes, and volcanoes were opportunities for adaptation, not constant existential threats. The contrast between Mars and Earth may have shaped the very instincts of life itself. From a harsh, declining world to a fertile and stable one, the lessons of resilience, resourcefulness, and foresight would have been embedded in the survival strategies carried forward. Water, once rare and precious, was now abundant. Radiation, once a constant danger, was largely mitigated. Nutrients and fertile soil offered tools for sustenance and growth. Opportunities to build, explore, and innovate were finally available. In this light, Earth becomes more than a home. It becomes the continuation of a story begun elsewhere. A story that began in deserts and ice on Mars, learned the art of endurance, and arrived on a world ready to sustain life for billions of years. Our curiosity, our urge to explore, our ability to adapt and survive in challenging environments, all may be whispers of a distant past on a red planet that once called life into being. Even the oceans, winds, and mountains of Earth may carry subtle echoes of lessons first learned on Mars. The preciousness of water, the necessity of shelter, the careful stewardship of fragile resources. Perhaps buried deep within our biology, or even within instincts we barely understand, lie traces of a world that no longer exists, a planet that shaped resilience, curiosity, and the drive to explore. Earth, in contrast, was not merely survivable, it was abundant. Its youth and vitality provided opportunities that a declining Mars could no longer offer. While Mars had already passed its peak of habitability, Earth was just entering its prime. Its surface was active, its climate increasingly stable, and its oceans, rivers, and fertile soils were rich and welcoming. For any civilization looking for a new home, the timing could not have been better. To leave a dying world and arrive on a flourishing one would have been like stepping into the opening chapter of a new story. A world ready to receive life and sustain it across millennia. This migration may not have been a single, decisive journey. Perhaps it occurred in waves, with early attempts faltering or disappearing, leaving only faint traces, while later efforts established enduring settlements. The crossing from Mars to Earth, even if undertaken by advanced technology or guided biological means, would have been immense and dangerous, a test of ingenuity and perseverance. Yet once life reached Earth, the pressures of survival eased. The climate was more forgiving, radiation less intense, and resources far more abundant. Earth, as a second home, also offers a profound perspective on humanity's deep bond with this planet. Our connection may run deeper than mere birthplace or habitat. It could be a continuation, a safeguard, a sanctuary for life that began elsewhere. If our distant ancestors originated on Mars, then Earth became their refuge, a canvas on which survival, adaptation, and knowledge could flourish. In this way, our story may be the continuation of an epic begun on another world, a story of resilience, migration, and hope carried across the void of space. In every river that flows, every forest that spreads across a continent, and every breath drawn from the atmosphere, there may be echoes of that first struggle to survive. Earth's abundance is a gift, but also a reminder of the fragility of life and the effort required to sustain it. And perhaps, somewhere in our DNA, in the spark of curiosity that drives us to explore, to climb, to build, and to seek new horizons, lies a memory of a red world that taught us how to endure, how to imagine, and how to carry life forward against the odds. Over time, that Martian origin would fade into myth, and Earth would become the center of the story. From the perspective of cosmic history, this sequence makes sense. Mars, smaller and less stable, may have offered the first window for life. Earth, larger and more resilient, offered the longer future. If humans came from Mars, then Earth was the inheritance, more fertile, more generous, and capable of sustaining civilization, not just for millions, but for billions of years. In this way, Earth was not just a younger world. It was the safer one, the one that could carry life forward long after Mars had lost its chance. For us, it became the final home. But in this speculative story, it was once the second home, chosen by necessity when the first could no longer last. If humans or their ancestors once lived on Mars, then the most difficult question is also the most fascinating. How could they have made the journey to Earth? The idea of an entire species moving from one planet to another seems overwhelming. Mars, in its quiet desolation, invites this imagination. Its valleys, craters, and plains are not only geological records, but also canvases for hypotheses about life, intelligence, and civilization. The history of a lost world is written in the subtle signatures of rocks, sediment layers, and mineral deposits, waiting for careful eyes and patient exploration to reveal the faint outlines of a story long forgotten. Whether or not humans or their ancestors ever walked there, Mars reminds us that planets are not static. They live, change, and fade. And in the gaps left by time, it is the imagination that allows us to glimpse the lives that may have once flourished in ways we can only begin to imagine. Food would have been another pressing concern. On Earth, agriculture depends on fertile soil, stable temperatures, and abundant water. On Mars, even in its early habitable phase, these conditions would have been precarious. Any intelligent beings would have needed to develop ways to grow food in controlled environments, perhaps underground, in caves, or in sheltered valleys. Hydroponics or other water-efficient methods may have been their solution, making every drop of water precious. Energy would also have been a constant challenge. Mars is farther from the sun than Earth, so sunlight is weaker and seasonal variations more extreme. Harnessing energy from sunlight, heat, or even volcanic activity may have been vital for survival. Fires, furnaces, or chemical energy derived from minerals could have powered essential tasks, from heating shelters to processing food and water. Every technological solution would have required ingenuity and foresight. Open-air living would expose inhabitants to radiation and dust storms, which could last for weeks or months. Underground tunnels, insulated caves, or perhaps bioengineered habitats might have provided protection. These refuges may have doubled as community centers, laboratories, and storage for resources. The architecture of survival, if it existed, would have been dictated entirely by necessity rather than aesthetics. Communication and culture may have been equally constrained by the environment. Long distances between habitable zones, coupled with extreme weather, could have made travel difficult. Communities may have been small, dispersed, and highly interdependent. Knowledge, rituals, and technology would need to be preserved and transmitted carefully, perhaps encoded into stones, minerals, or underground chambers designed to survive the harsh surface conditions. Health and biology would also have posed challenges. Lower gravity, a thinner atmosphere, and increased radiation could have affected the physiology of any intelligent life. Adaptations might have included stronger cellular repair mechanisms, resistance to radiation, or behaviors that minimized exposure to the surface. Life on Mars would have been a continuous negotiation between biological limits and environmental demands. Even in such a harsh world, curiosity and observation may have flourished. Studying the stars, tracking the sun, and observing seasonal changes would have been both practical and cultural pursuits. Understanding the planet itself, its winds, ice, water flows, and volcanic activity would have been essential to survival. Knowledge would not just be wisdom, it would have been the very tool of life, a bridge between survival and insight. The decline of the planet, gradual yet inexorable, would have shaped every aspect of life. As water receded and temperatures fell, the pressure to innovate, civilizations may have focused on storing food, capturing water, and insulating themselves from radiation. They may have developed technologies we can only imagine, perhaps even contemplating escape beyond Mars, preserving life in forms that could endure the coming cold and dryness. And yet, the passage of billions of years has left the surface as we see it today silent, rust-red, and barren. Any cities, farms, or subterranean habitats have long since disappeared, leaving only the landscape shaped by water, wind, and time, as the faintest record of a world that might once have been alive. To imagine humans or intelligent beings living on Mars before Earth is to consider survival it is to imagine ingenuity born of necessity, societies formed around scarce resources, and civilizations that faced the slow decline of their home world. It reminds us that intelligence, even if it arises, is always subject to the environment, fragile and fleeting in a universe governed by change, even without evidence. This vision transforms how we view Mars. It becomes not merely a frozen desert, but a stage where life may have once danced briefly in the warmth of water and atmosphere. The possibilities stretch from the microscopic to the intelligent, from early microorganisms to the hint of culture, and perhaps even the faintest glimmer of a civilization struggling to survive. Mars challenges us to imagine resilience, adaptation, and the courage to endure when a world itself begins to fail. Food, too, would have been a constant concern. Without fertile soil or abundant rainfall, growing crops would have demanded innovation. Perhaps hydroponics, underground gardens, or nutrient-rich algae pools sustained them. Every meal may have depended on careful management of water and soil, making agriculture a daily act of survival and ingenuity. Energy would have been another puzzle. Sunlight, though weaker than on Earth, could have powered solar collectors, while volcanic heat or chemical reactions in the soil might have been harnessed for warmth, light, and industrial tasks. Fuel and energy storage would have been vital, as any lapse could threaten lives. Shelters may have been monumental, yet utilitarian, buried beneath layers of rock to protect from radiation and dust storms. Cities might have stretched into caves or hollowed out lava tubes. Surface structures, if any, would have been built with materials resistant to wind and radiation, perhaps lightweight composites or stone reinforced with natural resins. Communication and transportation would have shaped society in profound ways. With scattered water sources and harsh terrain, communities may have been small and dispersed. Trade, knowledge transfer, and cultural exchange would have relied on ingenuity, perhaps involving enclosed tunnels, signal systems, or long-range vehicles capable of navigating deserts and craters. The mental and social toll of living under constant environmental pressure cannot be understated. Every generation would have inherited the responsibility of survival, problem-solving, and maintaining technologies critical to life. Cultural rituals, storytelling, and communal activities may have served not just social purposes, but practical ones, passing down knowledge, reinforcing cooperation, and remembering the ever-present fragility of existence. Even in such conditions, curiosity may have persisted. Observation of the stars, tracking seasonal changes, and mapping the land could have been both practical and ceremonial. Knowledge of the planet itself, its winds, ice, water, flows, and volcanic activity would have been essential for survival, making science and culture deeply intertwined. As Mars's atmosphere thinned and water disappeared, the pressures would have intensified. Civilizations would have faced choices: adapt by moving underground, develop technologies to conserve and recycle resources, or leave. Departure may have seemed like the only option for long-term survival, making Mars a planet not only of endurance, but of inevitable migration. If humanity or life destined to become human truly originated on Mars, then our earliest ancestors faced a world far harsher than Earth. They lived with scarcity, adapted to radiation, and managed climate extremes that would challenge even the most advanced modern technology. Survival was never guaranteed. Every day was a negotiation with the planet itself. In imagining life on Mars, we begin to see not just the possibilities, but the profound difficulties. Intelligence and civilization are remarkable, but even they are constrained by the environment. Mars teaches us that survival depends on ingenuity, cooperation, and a deep understanding of the world one inhabits. The combination of dwindling water and rising radiation would have made daily life a constant struggle. Agriculture, energy production, and even simple travel would have demanded ingenuity and careful planning. Communities may have become smaller and more isolated, each settlement forced to manage its own resources with extreme efficiency. Social organization would have been crucial. Leadership, cooperation, and shared knowledge could have meant the difference between survival and collapse. Every generation would inherit the knowledge of how to cope with a planet in decline, learning from the mistakes and successes of their ancestors. Even with the best adaptations, a point would inevitably arrive when survival required looking beyond Mars itself. Perhaps this is where the idea of migration first emerged. Observation of Earth from the sky, perhaps as a small blue dot in the distance, could have presented a tantalizing alternativa, planet rich in water, with a thick atmosphere and abundant resources. For a civilization facing the slow demise of its home world, Earth would have been more than a possibility. It would have represented hope, a second chance for life to continue. Yet, when we break it down, there are a few ways this migration could have taken place. Some rely on natural processes, while others assume a level of technology advanced enough to plan such a crossing. One possibility is that life moved unintentionally, carried on fragments of rock. We know that asteroid impacts on Mars have been powerful enough to launch pieces of the planet into space. Some of these rocks eventually landed on Earth, where we have found them as meteorites. If microbes were living inside such rocks, shielded from radiation by layers of stone, they could have survived the journey. This idea is known as panspermia, the transfer of life between planets. In this scenario, Mars did not need to send humans directly. It only needed to send the seeds of life, which could then take root on Earth and eventually evolve into us. Another possibility is more deliberate. If Mars once had a civilization advanced enough to understand its own decline, it might also have developed the ability to travel between planets. Such a civilization could have built spacecraft capable of carrying people, knowledge, and tools across the gap. The distance between Mars and Earth is large, but not insurmountable. Modern humans are already planning missions to Mars using rockets. If an older civilization had even more advanced methods, then a migration, though difficult, would not have been impossible. The journey itself would have required planning on a massive scale. Transporting not just individuals, but entire communities would have been essential for survival. They would have needed to bring food, water, and the means to build a new life once they arrived. Earth, while abundant, would not have been instantly familiar or easy to inhabit. Early settlers would have had to adapt to new ecosystems, climates, and perhaps even dangers they had never encountered before. There is also the chance that migration was gradual. Instead of one great exodus, small groups may have made the journey first, establishing footholds on Earth over generations. More may have followed until the Martian presence on Earth grew strong, enough to replace what was lost back home. This slow process would also help explain why no clear evidence of a sudden arrival remains in Earth's archaeological record. The transition from Mars to Earth could have blended into the deeper flow of evolution, leaving behind myths rather than monuments. Some researchers speculate that if such a migration happened, it may not have been physical at all, but genetic. Martians could have sent engineered organisms or genetic material designed to thrive on Earth. Over time, these forms of life may have developed into what we now recognize as humanity. This version of migration does not involve ships or cities crossing space, but the careful transfer of information, life encoded into biology, preserved and seeded on a new world. No matter which scenario we imagine, the central idea is the same. Mars was losing its ability to support life, and Earth was gaining it. For survival to continue, the story had to move from one planet to the other. Whether by accident, by design, or by necessity, the crossing may have taken place. And once on Earth, the memory of that origin could have faded, leaving only hints in myth, speculation, and the silent landscapes of Mars itself. If humans or their ancestors once came from Mars, another question naturally follows. Where is the technology that would have made such a migration possible? To leave one planet and settle on another would require tools, machines, and knowledge far beyond what we see in the early history of Earth. Yet, when we look at our past, there are no clear signs of advanced technology stretching back into the distant ages. This absence is one of the biggest challenges to the idea of Martian origins. On Earth, human civilization as we know it is young. The first cities appeared only a few thousand years ago, and even the earliest stone tools are no older than a few million years. If a Martian civilization existed billions of years ago, and if it brought people or life to Earth, we should not expect its technology to still be visible. Time erases almost everything. Even here on Earth, where conditions are far more favorable, ruins and artifacts can vanish quickly. Wood rots, metals corrode, and even stone structures wear down in only a few thousand years. Over millions or billions of years, almost nothing would remain. On Mars, the situation would be even harsher. Without a protective atmosphere, the surface is constantly bombarded by radiation and micrometeorites. Dust storms grind away at exposed surfaces, and the freeze-thaw cycle cracks and breaks down rock. Over billions of years, any structures left on the surface could be reduced to rubble or buried beneath layers of sediment. If machines or artifacts once existed, they might now lie deep underground, hidden from our current view. It is also possible that Martian technology was not like ours at all. We imagine metal, stone, and glass because that is what we use. But another civilization might have relied on materials that were more organic, temporary, or renewable. If their tools were made of substances that break down quickly, then it would not be surprising that we find no trace of them today. Technology does not always leave a fossil record. Another point to consider is that migration from Mars to Earth may not have required large-scale infrastructure as we imagine it. If the transfer was genetic, involving microorganisms or engineered life, then the technology may have been biological rather than mechanical. In that case, what was carried across space was not a ship full of people, but encoded information capable of restarting life on Earth. The tools of such a process would not look like machines at all, and they may leave no recognizable trace. Even if a Martian civilization had built spacecraft or advanced machines, there is no guarantee that such knowledge would have survived the journey. Migrating to a new world could have meant starting over with the basics, using only what was immediately available. Technology may have been lost in the process, either by necessity or by choice, as survival on a new and unfamiliar planet became the priority. Human history shows how fragile knowledge can be. Entire libraries have been destroyed in fires. Skills once mastered have been forgotten for centuries. Civilizations that reached impressive levels of development have vanished, leaving behind only fragments. If this happens over thousands of years, it is easy to imagine what could be lost over billions. The absence of Martian technology does not prove that it never existed. It may simply mean that time has erased it. If humans did come from Mars, then Earth itself became the place where our technological story began again from near zero. What we see as progress may be in truth a recovery from an earlier loss. If humans once lived on Mars before Earth, the memory of that origin may not have survived in physical form. Technology, structures, and artifacts could have been erased by time. But ideas are different. Stories, myths, and symbols often lasts far longer than the objects around them. They can carry fragments of forgotten history passed down through generations, even as their original meaning fades. If we look at ancient myths closely, it is possible to wonder whether they contain traces of a Martian past. Many cultures have myths of beings who came from the sky. Sometimes they are described as gods, sometimes as ancestors, and sometimes as teachers who brought knowledge. These stories appear in widely separated parts of the world, from Mesopotamia to the Americas to Australia. While it is easy to explain them as symbolic or spiritual, they could also reflect distant memories of migration events, so old they became myth rather than history. The planet Mars itself has long been linked with powerful symbolism. Ancient civilizations gave it names tied to war, fire, and strength, likely inspired by its reddish color. But the fact that Mars stood out so clearly in the night sky may have carried deeper meaning. If humanity had a hidden connection to Mars, it would not be surprising that the planet became central in myth. The association may not have been remembered directly, but the sense of importance could have endured. Some myths also speak of great floods, lost homelands, or civilizations destroyed by environmental collapse. While these are often connected to events on Earth, they might echo something older. If a civilization on Mars faced the slow loss of water and atmosphere, the memory of leaving a dying world could have transformed into stories of catastrophe, passed down through countless generations. Such stories might have become legends of worlds before this one, remembered not with precision, but with symbolism. The idea of humans being placed on Earth by higher beings is another recurring theme. Many traditions describe humanity as having been guided or created by entities beyond the Earth. In a literal sense, this is usually taken as spiritual or divine. But if interpreted through the lens of Martian origins, such myths could be distant echoes of ancestors who carried life from one planet to another. Over time, practical acts of migration could have been retold as sacred acts of creation. Even language itself holds small clues. Words for heaven, sky, or stars are often tied to ideas of origin. Across cultures, people have looked upward when asked where they came from. While this is often seen as a natural human instinct, it could also be a reflection of deeper memory and intuition that our beginnings are not entirely rooted in the soil of this planet. Of course, myths are not evidence. They cannot prove that humans once lived on Mars, but they do show how powerful and persistent the idea of coming from the sky has been across human history. If there was ever a migration from Mars to Earth, the memory of it would likely not survive as history. It would survive as story retold, reshaped, and reimagined until its original meaning was lost. What we have today may be fragments of those memories carried forward in myths that still whisper of other worlds. If humans truly had their beginnings on Mars, one way the connection might still be visible is in our biology. Technology and monuments may vanish, but the genetic code carried in every living cell is far more durable. The idea of a genetic link between Mars and Earth suggests that life here may not have begun entirely on its own. Instead, it may have inherited something from an earlier origin across space. The simplest form of this idea is called panspermia. It proposes that microorganisms can travel between planets carried inside rocks blasted into space by impacts. We know this process is possible because Martian meteorites have been found on Earth. They were launched into space when asteroids struck Mars with enough force to eject pieces of its surface. And eventually, some of those fragments fell here. If tiny organisms were protected within those rocks, they could have survived the journey. Once on Earth, they might have taken root in the oceans and multiplied over billions of years. Those first seeds could have evolved into the life we see today, including us. This version of the story does not require a Martian civilization. It only requires that life began on Mars earlier than on Earth, and that it had time to spread before Mars lost its habitability. But there is also a more complex possibility. If intelligent beings existed on Mars, they might have taken a more deliberate role in shaping what would come after them. They could have sent genetic material or even engineered organisms designed to survive on Earth and continue the story of life there. In this way, humanity could be both Martian and earthly, born of one planet but nurtured by another. What would such a genetic link look like? In some ways, it would be invisible. DNA follows universal rules, built from the same molecules, regardless of where it originated. If Martian life had the same basic chemistry as Earth life, then the connection would be hidden within the code itself. It would not look alien. It would look like us, yet there might still be clues. Some researchers have noted that the timeline of Earth's earliest life seems surprisingly quick. Geological evidence shows that as soon as Earth became stable enough for life, microorganisms were already present. This has raised the question of whether life truly began here or whether it was introduced already formed from somewhere else. If life came from Mars, this rapid appearance would make sense. Earth would not have had to start from zero. It would have received a head start. Another clue lies in the resilience of microorganisms on Earth. Some forms of bacteria can survive extreme heat, cold, radiation, and pressure. These organisms, called extrophiles, could endure the harsh journey through space far better than more fragile life forms. If any living beings could travel from Mars to Earth, it would be them. And once they arrived, Earth's oceans and atmosphere would have given them the opportunity to expand in ways Mars could no longer support. The idea of a genetic link between planets shifts the way we think about our place in the solar system. Instead of being a purely Earth-born species, we may carry the legacy of Mars within us. Our DNA may hold not just the record of life on this planet, but the memory of another world where the story first began. When we look at the official timeline of human history, civilization is a recent development. Agriculture began only about 10,000 years ago. Cities followed soon after, and writing systems are only a few thousand years old. Before that, humans lived as hunter-gatherers for hundreds of thousands of years. Yet, scattered throughout archaeology, there are discoveries that do not always fit neatly into this timeline. Some of these findings have been explained, others remain debated, and a few continue to raise quiet questions. Could any of them point, however faintly, to an origin that extends beyond Earth? One of the puzzles is the sudden appearance of advanced knowledge in some ancient cultures. For example, early civilizations in Mesopotamia, Egypt, and the Indus Valley developed writing, architecture, astronomy, and mathematics in ways that seem to appear almost fully formed. Traditional archaeology explains this as the result of long cultural development that left few traces, but some researchers wonder if these leaps in knowledge reflect fragments of something older, perhaps carried forward from a forgotten past. If there were survivors of an earlier world, even one from beyond Earth, their influence could appear as sudden advances in human history. Another set of mysteries comes from megalithic structures found across the world. From the pyramids of Egypt to the stone circles of Britain to the vast stone platforms of South America, many ancient monuments continue to challenge our understanding of early engineering. These structures were built with great precision, often aligned with astronomical events and sometimes using stones weighing hundreds of tons. While they can be explained as remarkable achievements of human ingenuity, they also raise the question of whether ancient builders inherited knowledge rather than inventing it entirely on their own. There are also artifacts that seem out of place in their context. Occasionally, objects are found that appear too advanced for their supposed age. Some of these are later shown to be mistakes or misinterpretations, but a few remain unexplained. While most archaeologists are cautious about these claims, they fuel speculation that fragments of a much older, forgotten technology may still exist, buried within Earth's layers of history. Even myths tied to archaeology add to the curiosity. Many cultures speak of lost civilizations, Atlantis, Lemuria, or other lands said to have vanished in catastrophe. These stories often describe destruction by water, fire, or climate change. While they are not evidence in themselves, if Mars once hosted life or civilizations, its end may have been remembered on Earth, not as history, but as legend. The archaeological record on Earth is incomplete and always will be. Organic materials decay, landscapes change, and entire regions of the past are lost to erosion or buried under new layers. It is possible that if Martian origins played a role in human history, their traces are hidden, misinterpreted, or simply gone. Yet the unanswered questions in archaeology, the sudden leaps, the unexplained precision, the stories of lost worlds keep the door open, however slightly, to deeper possibilities. This does not mean that every mystery points to Mars. Most have more practical explanations within Earth's own history, but the very existence of such questions shows how much we do not yet know. And in that space of uncertainty, it is possible to imagine connections that reach beyond this planet, suggesting that the roots of humanity may go back further than we think, perhaps even to another world entirely. If humans once lived on Mars before Earth, the question many people ask is obvious. Why is there no clear proof? Why have we not found ruins, artifacts, or even fossils that confirm such a history? The answer may lie in the nature of time, erosion, and the limits of what we are able to recognize as evidence. The first factor is simply age. If Mars had a habitable period, it was billions of years ago. On Earth, we struggle to preserve traces of civilizations only a few thousand years old. Wood, cloth, and even metal vanish quickly. Stone can last longer, but even it erodes with time. Over the span of millions of years, entire cities can vanish. Over billions, almost nothing remains. Expecting to find intact structures on Mars from such a remote period may not be realistic. The surface of Mars is also an unforgiving environment. Without a strong atmosphere, it is constantly bombarded by radiation, solar wind, and micrometeorites. Dust storms sweep across the planet, wearing down exposed surfaces. Temperatures swing drastically between day and night, cracking rock through cycles of freezing and thawing over immense stretches of time. These forces would erase or bury nearly everything. Even if large structures once stood, they could now be reduced to rubble that is indistinguishable from natural formations. Another challenge is how much of Mars we have actually studied. Despite decades of exploration, only a small fraction of the planet has been examined up close. Rovers have traveled only a few dozen km in total, and orbiters, while powerful, can only capture details from a distance. Most of the surface remains unexplored. If there are traces of a past civilization, they may simply lie in regions we have not yet reached or hidden beneath the ground, where current tools cannot detect them. It is also possible that we do not yet know how to recognize the evidence, even if we see it. We assume that advanced civilizations would build in ways familiar to us: stone, monuments, metal tools, geometric patterns. But what if Martian technology was different, relying on materials or methods that leave little trace? On Earth, even advanced technologies can disappear without a record if they are made from fragile materials. A society that relied on biological or renewable systems might have left behind almost nothing we would recognize today. There is also the possibility of deliberate. If a Martian civilization reached a point of decline, it may not have had the ability or desire to preserve its history. Knowledge could have been lost as survival became the priority. By the time migration or extinction occurred, much of their cultural and technological record may already have vanished. What little remained would have been left to the slow processes of erosion and decay. On Earth, the problem is similar. If early humans or life from Mars arrived here, they may not have carried physical evidence of their origins. Over tens of thousands of generations, any memory of migration would have turned into myth. While the physical traces were consumed by time, we may still be searching for evidence that by its very nature no longer exists. The absence of clear proof does not mean the idea is false. It may simply mean that we are asking the wrong questions or looking in the wrong places. Evidence of such an ancient and extraordinary history, if it exists, may be far subtler than we expect. It may lie not in ruins or artifacts, but in genetic patterns, geological anomalies, or fragments of memory carried through myth. For now, the story remains hidden, waiting for new ways of seeing that might reveal what has been overlooked. When we consider the possibility of humans once living on Mars, the greatest obstacle is not imagination, but time. The timeline involved stretches so far back that it is difficult to grasp. Billions of years have passed since Mars is thought to have been habitable. Over such a scale, almost everything familiar to us, buildings, artifacts, even landscapes, would vanish. Understanding how time erases history helps explain why we may not see direct evidence of a Martian past. On Earth, traces of civilization disappear quickly. Wooden structures may last only a few centuries before rotting. Metals corrode in a matter of millennia. Even stone, which seems permanent, eventually breaks down under the forces of weather and erosion. Entire cities, once thriving, can vanish beneath soil, sand, or vegetation in only a few thousand years. In archaeology, we often uncover just fragments of pottery or foundations, and even these are rare. If so much of Earth's history fades in a short span, then expecting traces from billions of years ago on Mars or anywhere else may be unrealistic. Mars faces its own challenges without a thick atmosphere or magnetic field. Its surface is exposed to constant radiation from the sun and from space. Radiation breaks down chemical bonds and gradually destroys organic material. Micrometeorites bombard the surface, slowly grinding away at exposed rock. Dust storms sweep across the planet, scouring surfaces and burying features beneath shifting sands. Over immense stretches of time, these forces would erase nearly all evidence of anything artificial. Geological activity also plays a role. On Earth, plate tectonics recycle the surface, drawing ancient crust into the mantle and replacing it with new rock. This is one reason we find so little of Earth's earliest history. Most of it has been destroyed. Mars does not have plate tectonics in the same way, but volcanic flows, impacts, and erosion have reshaped its surface many times. Older layers may be buried beneath newer ones, making them difficult to access without deep exploration. Time erases not only physical structures, but also memory. Older traditions can preserve stories for thousands of years, but eventually they fade or change. Written records extend further, but even they are fragile. Scrolls burn, tablets break, and libraries disappear. If a Martian civilization existed billions of years ago, there is no reason to expect its records would survive. By the time life continued on Earth, whatever memory of Mars remained would likely have been reduced to myth, symbol, or instinct, fragments of a story without context. This perspective changes how we think about history. We often imagine the past as a chain of events that can be traced backwards, step by step. But in reality, the deeper we go, the more gaps we encounter. What survives is only a fraction shaped by chance. Most of human history is already lost. And beyond that, most of Earth's history is gone as well. On the scale of billions of years, even entire civilizations could vanish without leaving more than a trace. If humans truly once lived on Mars, time itself may be the reason we cannot prove it. The world has simply turned too many times since then. What remains is not clear evidence, but faint possibilities. Landscapes that look shaped by water, myths that speak of worlds before this one, and the quiet intuition that our story may reach back further than we know. In the face of deep time, certainty is rare. What survives are only questions. When we think about human history, we usually see Earth as the beginning. It is the place where life emerged, evolved, and eventually became us. The idea that humans might have once lived on Mars changes that story in subtle but significant ways. It does not erase what we know about Earth's past, but it expands it into something larger, a history that may stretch across more than one planet. The first change is in how we see Earth itself. Instead of being the absolute cradle of humanity, Earth becomes a refuge, a second home. If Mars was our first world, then Earth represents continuity rather than origin. Our species would be shaped not only by the abundance of this planet, but also by the memory, whether genetic, cultural, or symbolic, of surviving another world's decline. Earth becomes the place where life was preserved after its first home was lost. The second change is in how we think about time. Human history is usually measured in thousands of years, with prehistory extending into a few 100,000. But if our story includes Mars, then the timeline extends by billions of years. It becomes part of planetary history rather than just terrestrial history. Humanity is no longer a recent phenomenon on Earth alone, but a participant in a much older, longer process that began before Earth was ready to support us. This idea also shifts the way we think about civilization on Earth. We see civilization as something that emerged only once after humans had evolved here. But if Mars once hosted intelligence, then civilization may not be a unique event. It may be something that rises, falls, and rises again, moving between worlds as conditions change. What we see as our first achievements may instead be echoes of a deeper cycle. The idea changes how we view exploration as well. When we look at Mars today, we usually imagine it as a destination for the future. But if humans once lived there, then exploration is not about moving forward, but about returning. Going to Mars would be less about conquering new ground and more about rediscovering old ground. A journey back to the place where our story may have begun. Finally, this possibility affects how we think about survival. If humanity did once migrate from Mars to Earth, it suggests that our existence is already tied to planetary change. We would not be the first species to adapt to a new world, but the continuation of a story that survived one planetary crisis and found new life elsewhere. That perspective makes the challenges we face today, climate change, resource use, and sustainability, feel different. They are not just modern problems. They are part of a much older pattern, one where survival has always depended on adaptation and movement. In the end, the idea that humans once lived on Mars does not need to be proven for it to change how we think. It reminds us that history is vast, that time is long, and that the story of life may be far more complex than the version we currently accept. Whether true or not, it expands our sense of possibility, opening the door to a version of human history that is not limited to a single planet, but stretches across worlds. The idea that humans may have once lived on Mars before Earth is not something we can prove, at least not with the evidence we have now, yet. It remains a possibility worth considering because it challenges the way we see ourselves and the history of life in the solar system. When we take the long view, stretching across billions of years, the line between certainty and speculation grows thin. What is left is a space where questions matter as much as answers. Mars today seems empty, a quiet desert world, but its past tells another story of rivers, lakes, and climates that could have supported life. Whether that life was simple or complex, microbial or intelligent, we do not yet know. But we do know that Mars once had what life needs: water, atmosphere, and energy. In that sense, it was never just a barren planet. It was a world that had its chance. If humanity's roots reach back to Mars, then our story is older and wider than we think. Earth becomes the second chapter rather than the beginning, and Mars becomes the silent first home that we left behind. Perhaps fragments of memory remain, carried in myths of beings from the sky, or in the deep structure of our DNA. Perhaps the connection is gone entirely, erased by time. Either way, the possibility changes how we think about both worlds. It also changes how we look at the future. If our ancestors once left Mars to survive, then space migration is not something new, but something humanity has already done. The idea of leaving one planet for another becomes part of our history rather than just our ambition. In that sense, the challenges we face today, whether on Earth or beyond, are not unique. They are part of a larger cycle where survival has always meant moving forward into the unknown. Speculation about Martian origins does not need to be conclusive. It serves another purpose: to remind us of the vastness of time and the fragility of history. Civilizations rise and fall. Planets change and evidence fades. What remains are questions, traces, and the quiet landscapes of other worlds that still hold secrets we have not yet uncovered. As we continue to study Mars, we may one day find clearer answers. A fossil, a chemical signature, or a buried structure could transform speculation into knowledge. Or we may never find such evidence, leaving the question open forever. Either way, Mars will remain more than just another planet in the sky. It will remain a mirror reflecting our curiosity about where we come from and where we might go. For now, the story is unfinished. We stand on Earth looking up at Mars, wondering whether its empty valleys once carried not only rivers, but also lives connected to our own. The truth may never be fully known, but the act of asking the question keeps us aware of the greater scale of our history, a history that may stretch across planets, carried forward through survival, adaptation, and the persistence of life itself. And so, as we gaze up at the red planet from our blue home, we are reminded of the fragile beauty of life and the vast, unfolding story that may connect worlds across time and space. Mars, once alive with rivers and lakes, may have shaped the beginnings of our own journey, teaching resilience, adaptation, and the courage to venture beyond what is known. Earth became a sanctuary, a new chapter, where life could continue, grow, and flourish. Perhaps somewhere deep within us, we still carry traces of that first home, the lessons learned, the struggles faced, and the hope that drove a civilization to survive against all odds. Every breath, every step upon this planet is a continuation of that story. The rivers that carve valleys, the winds that shape mountains, and the oceans that ebb and flow, these are reminders that life endures, even when worlds change, as we drift into thought and dreams. Let us imagine the rivers of ancient Mars, the hidden lakes beneath its surface, and the civilizations that might have risen and fallen beneath its skies. Let us feel the quiet rhythm of survival, the whisper of curiosity, and the eternal pulse of exploration that continues in us today. Life is a journey across time, space, and possibility. From the red deserts of Mars to the fertile lands of Earth, the story goes on. And in that story, we find not only questions, but the gentle certainty that life, in all its forms, seeks to endure, to adapt, and to explore. Good night from Earth Analyst, and let your mind wander among the stars, imagining worlds once alive, and the journeys that continue in the quiet of our dreams.